Hello, welcome to this next very exciting instalment of Clinker Chat. I am really pleased to be here in the Swinburne 3D printing lab, which is just phenomenal, and we'll move you around in a moment so you can have a little look at it. I am Claire, your host, CEO of the SmartCrete CRC. Really excited to be here with you today and with two absolute leaders in this field, Professor Jay Sanjayan, who is the head of the 3D printing lab here in Swinburne University, and John Croft, who is the head of John Croft Consulting and a real leader in the space of 3D printing. Before we get started today, I'd like to recognise the traditional owners on the land on which we meet you here today, which is the Wiradjuri people. We are at Swinburne University and very pleased to recognise elders past, present and emerging, particularly as we have conversations around sustainability and how we better use our natural resources in building our built environments. So yeah, really fabulous to continuously think about the lessons we can learn from our first people. Fabulous conversation that we're going to have today. I think, 3D printing is such an exciting and emerging space. We're obviously surrounded by some incredible equipment here and some beautiful examples of 3D printing. I wonder, John, if I could start with you and just ask, what is the application? What are we going to use 3D printing for?
Well, I suppose the best way to think about it, if we're here talking primarily construction, 3D printing, as we know, goes across polymers, metals, ceramics, bio, medical. There's not an industry that will not be touched, and this was a thought pattern or visualization I had back in 1993. But anyway, that was a little while ago. Listen, the construction industry, it has so much potential. And as we know, we've got shortages in materials, shortages with labour, and physical costs in building of housing and that for people. And of course, with the latest government, Spruik is talking about wanting to build 1 million homes. Well, I'm still trying to work out how that's going to work. But anyway, we'll wait and see on that front. But 3D printing, definitely. We're probably quite a few years behind, if I'm correct, Jay. But they've been going at this in the US and Europe for quite some time. Saw the first 3D printed pods or small little units done in 2007, I think it was, in Suzhou in China with a company called Winsun then. So it started way back then, and it's certainly making some inroads now. And here in Australia, we're really at the infancy of it. And if industry is really interested, then it's, to me, is a no-brainer, is working with research institutes such as Swinburne and Jay on developing the not just the around the equipment and the process, but also the materials.
Right. Because there do seem to be two components to this which really, change the way we think about how we build with concrete. One being the machines that we use in order to do this, but two being the mix. Jay, could you tell us about what some of the research challenges are that you're addressing in this space?
So, John, I just need to say Australia is not far behind. In terms of research, we are the leaders. Swinburne is, in terms of research publications, we rank number 1 in the world. Number 2 is TU Dresden, and Victor is also here on a sabbatical for 6 months. So we've joined forces, the number 1, number 2 in the world in terms of research and publications. That's not to say the industry, in terms of industrial applications, we haven't progressed same as China or
That's what
Europe
I was.
or other places.
Yeah.
But we have got good funding in terms of research that has been translated into research publications. So in terms of technology, we are up at the top, but in terms of commercial translation, we are behind, like that's what John mentioned.
And that's what I was referring
Coming
to.
back to your question, I forgot what the question was. I was
I
trying
wonder if, we're sat in this incredible space here where, I can see, and we will turn you around at some point, but I can see an incredible robotic arm here. There's a gantry system set up over there. What are some of the new technologies that you're developing here?
Okay. So there's a number of new things we're developing, and many of that's been published. One is sustainable alternative because, as you know, cement has this carbon emission issue. So we have been working on alternative cements like geopolymer cement and low carbon cement alternatives. But it's been very difficult to get that through construction industry because they have existing processes, existing machineries and supply chain, and there's a cost to change to low carbon alternatives. But here we are coming up with a totally new way of building. So there's an opportunity to start with low carbon alternatives. So I think that's one thing we are working on is to 3D printing, but with low carbon alternative, not follow the conventional cement. But in terms of challenges, 3D printing is still a lot more to learn and go before we can just ring up someone and say, I want my house printed by next Wednesday. But it's so in terms of reinforcement, how to put reinforcement in concrete. In addition, we are also working with some early startup companies on how to get the certification process through. So that's a very complicated pathway to finally achieve the certification. But fortunately, the Australian standard has been reformed in the last 2 decades to going from a prescriptive based specifications. It used to be that way many years ago, where the standard used to say how much concrete, how much cement should put, how much sand, and how to mix it, and how to place it, how to compact it. But now it's all performance based, so we are more going towards performance. So it gives us the flexibility to navigate the standard pathway for new innovative products. So which is good, but it's not an easy process. So that's another thing that we are currently working on with some industry. Yeah.
So thinking about that idea of, can you print me a house, for example, and what the benefits of, say, 3D printing might be over more standard construction methods. John, you were talking about 3D printing has huge benefits in terms of waste management.
Yeah.
Could you talk me through what does that mean?
All right, I suppose the best way of talking, if we look at global waste, 82% roughly is caused through construction. So it's a major industry that's producing a lot of waste, which is going into landfill. I think the benefit with the 3D printing, you're really only going to print what you use, or what you've got on site. You don't have extra as such. The other one is, of course, labour and time. Time is a big thing with printing, and as we said earlier, we're talking about 1 million homes. Well, if I can put one thing forward on a company that is here in Australia and has already printed a building, which was actually on the block. They set up on site, and of course that was in situ printing. They had a lot of issues, snow, wind, driving rain, all the rest of it. They were set up on site for 2 weeks, but actually the print took them 28 hours.
Wow,
so
incredible.
You've got to look at it that way. They used 34 tonne of mix to print the building. They had 80 kilos of waste total.
Wow.
So, and of course that comes from a lot of the cleaning from out of the lines and the extrusion head and that. So, and the pumps naturally that they're utilising. So they had 3 people on site.
Incredible.
So, which is really good. Yeah, no.
And another thing that, I think I've also recently become aware of is the question of formwork, right? And formwork being a huge part of the construction waste that happens. And this could be a pathway to eliminate formwork.
Oh, most definitely. I mean, I suppose that's the beauty with 3D printing. You're not limited as in shape, where traditional building and that sort of thing, if you're going to look at any organic sort of shape, you've got to do the formwork to do it. And formwork is a huge cost. It's 60% roughly the cost of the build. So if you can print it, it's so much cheaper.
And so formwork also contributes to a significant source of waste because often it's made of timber and it's temporary structure. So basically, to build a concrete structure, you have to first build a timber structure and pour the concrete. So timber is only the mold, and then you take the timber and throw away. You might use it a couple of times, a few times, but eventually it's a waste. So and that is that 3D printing can save a lot of waste, formwork waste, but it is also poses a challenge because the mold, the formwork, which is protecting the young, fresh concrete, which is a baby for someone like us working in concrete for a long time, and that protects that concrete for 24 hours, sometimes for 7 days they leave the formwork. So the concrete, until it becomes mature, the formwork protects the concrete from drying and cracking and so on. With 3D printing, that concrete, as soon as it's born, immediately exposed to the environment. So in terms of drying, there's no protection, shrinkage. A lot of, before COVID, I traveled around China many times looking at constructions. They were printing real life buildings and so on. All of them, you see this crack. It's mainly because of shrinkage, because it's plastic shrinkage immediately exposed to drying. So these are challenges because we want to get to the formwork, but that comes with challenges.
This could be partly overcome too by going into prefab, as in building in a controlled environment.
I mean, we know how to control concrete, we know how to manage concrete. So these challenges can be overcome because there's enough knowledge and chemicals that you can add to concrete to overcome things, admixtures and so on. So the concrete technology is advanced enough to overcome these issues, but someone has to give some thought and R&D has to be done so that it's not you can just go and print straight away. These concrete need to be modified to be able to cope with the shrinkage, early age exposure, and so on.
And one of your students is directly looking into this concept of a kind of an amalgamation of the mix and the printing technology itself, looking at how you might put in additives right at the end, right at the pump, right?
That's right.
Could you talk us through that project?
Yes, that's because the whole idea of additive manufacturing started in polymers and metals, like John mentioned. Now we, construction industry, we are latecomers to this technology, and concrete obviously is the most suitable material for this. But if you look at polymers, they get melted and then come out and they immediately go hard. So they are strong enough to be kept building, similar to metal. As soon as they come out, they are strong enough to the next layer. But concrete takes a couple of hours, sometimes longer or sometimes shorter, to be strong enough to keep building. So the current technologies in 3D printing, you cannot build more than maybe 0.5 meter sometimes some mixers can go up to 1 meters, like that one sitting over there. But eventually they'll collapse. You can't keep building 2 meters, 3 meters like that. So the technology that we developed is using geopolymer, which is 2-part, and those 2 parts we mix it at the nozzle, and then it's got 30 seconds to a few minutes before it goes hard. So depending on the length of printing. So once it goes hard, we can keep printing. And we can keep printing for 3 meters, 5 meters, 10 meters, whatever length.
Fantastic.
So that
which would give you real flexibility to choose the right mixture, the right process of construction for the right application.
So we can adjust it to sort of, if you're building a large house, then you want to have more time between before the next layer comes. The previous layer should be soft enough to take the next layer, but once you go about another 10 layers, this layer should be strong enough.
Yeah.
So we have to adjust the timing. And the other thing that technology solves is at the moment, most of the people working in, they bring the concrete and add an accelerator at the end. The problem is that if we need to stop the printing process, you want to take a lunch break or whatever, you have to clean the whole system. Now with our system, the geopolymer, it just stays liquid for a few days. So you can even stop for today and come back tomorrow, continue without having to clean up the whole system.
Right, because you have that option of adding that, the additive right at the end as you need it.
It's a 2-part mix. It's like an epoxy.
Yeah.
So you have epoxies that you buy in Bunnings. It comes in 2 tubes, and they stay in like that for a long time. And then you mix it, and then you got 5 minutes.
Yeah.
So,
Brilliant.
so that is the similar type.
And one thing I imagine is a huge advantage of 3D printing is just the diversity of shapes that you're able to create. I think, again, we're sitting in this incredible lab here right now where I can see beautiful structural columns. I can see a kangaroo over there. Really, really fabulous, very organic shapes that are being made. Do you see, the benefit here is really allowing that diversity of creativity for architects and engineers and designers to think very creatively about the concrete shapes they create?
Most definitely, because they've always been hamstrung by traditional build. And if they want to do something that's totally out of the ordinary, normally it costs them an absolute fortune to do, which makes it not very feasible to do. With the printing side of it, imagination is your limit. I think in talking about design, I'm sure Jay will back me up, one of the things that we've got missing is people that really understand the process and actually design around what the process is going to give them. And I think that's something that will slowly evolve as the printing starts to take hold.
Fantastic.
Yeah, I think we need to work very closely with innovative urban designers, architects, and so on, who can come up with innovative design that take advantage of the 3D printing process. A lot of people want to build square houses, replicate exactly what we're doing with brick houses, which is okay. Even I've talked to a few builders who are working in this. They say there's significant cost reduction anyway, but taking advantage of the flexibility to do things that is too expensive to do with the conventional way, there's a lot more advantage for 3D printing. Look, for example, something like Sydney Opera House. It is an extremely complex shape, and it costs a lot of money to build, as you know. But that's type of organic shapes actually can express the 3D printing in a more. Actually, I have visited a company in Nanjing. They are doing exactly that. And that owner who had the vision, he said, first thing he did is hired a lot of designers. And they were all sitting there, and the local city council have lots of urban bus stops, urban architecture pieces. And they take that existing design and they come up with an alternative which is more interesting, and do a competitive tender, and they 3D print it and supply. And I think that's a successful profit-making company. So there are companies that are making profits in this area.
Phenomenal.
Yeah.
Well, John, you mentioned before that there's the 3D printed property that was created for the block, which I think many of us were really fascinated to watch. And yes, weather was absolutely the challenge for the entire series of the block. So that was very, very interesting. Can you tell us maybe about some of the projects that are happening overseas, where maybe we're really seeing the capacity of this
well,
technology?
you're seeing a lot of the companies working heavily overseas. I mean, Cobot, Icon, Black Buffalo, Alquist, just to name a few of them that are actually working. You got Azure, I think it is, that is working heavily in the thermoplastic and printing up sort of studio pods out of thermoplastic, which is really exciting because it's another thing that they've been looking into, and again, it's around the recycling. So they're looking at recycled plastics to print up these studio pods, which is absolutely fantastic. Here in Australia, I mean, we're at the infancy, and I'll correct myself, Jay. I mean, as far as globally, yeah, we are behind, but it's behind more so in the take-up of what's happening in Australia. We are slower on the take-up. As I said, the company, Contour 3D, was the company up in Sydney. Nick Holden, they did an absolute wonderful job, and it's probably one of the best print finishes I've seen in a long time.
Beautiful.
Yeah.
It really is stunning. Yeah.
The other, we've got other companies. I mean, there's Luton here in Melbourne who are developing 3D printers, and they're working now heavily with the Indigenous community. This is absolutely wonderful what's going to happen around Indigenous housing and that, and that's one that the government is focused on. There's another company up in New South just starting up at the moment called Flow 6D, and slowly but surely he'll start to make inroads. And they'll start popping up left, right and centre now.
There are
I
quite
think.
a few
Yeah.
coming up. I mean, I get a call every week. There's a new company, but Cobot is here.
Yeah, Cobot's here.
And as I mentioned, Victor Mesherin, he's a professor in TU Dresden in Germany. He's here for 6 months on sabbatical working with us at Swinburne. He told me yesterday, Pulsmeister, the world's #1 concrete pump company, they showed their system at the Bauma, which is the construction exhibition held in Germany every year. They showed their system last week at the Bauma exhibition. So basically they have the concrete boom pump, which then they turn that into a 3D printer. So that was a concept actually introduced by Victor himself 6 years ago at the Bauma exhibition, and they won the best prize for the best idea in 2016 or 17. And 5 years later, Pulsmeister took that idea and turned it into reality and showed it last week.
Wow.
So if you want to have a look at that one, that's called Carlos, K-A-R-L-O-S. If you YouTube it, you'll find that one.
Fantastic. Well, along that same line, I wonder if maybe you could talk us through some of the things that are happening here from a machinery perspective. So what's above our heads right now is some sort of gantry system. If I pull you back so that you can all see it as well. So right here above our heads, it's a bit hard to see. But could you talk us through the technologies that you're trialling here and the different methodologies for printing?
So this is a gantry system. It's similar to what Berok Koshnov is. He is the one who started this. He was a robotic engineer. He started this idea some, I think 15 years ago. And that's originally how it started, because it's a lot more stable, strong, easy to control. Koshnov still believes this is the best system in terms of controlling.
And an application for this would be, more what we were talking before about maybe precast as opposed to, moving this on-site.
Cobalt is similar system, but they are aiming for site construction. So this is not restricted. The gantry system not restricted to precast. But then CB, they use some similar to this kind of similar to ABB robot. So ABB robot that has 6 axes, easy to control, but some people believe it doesn't have the same control if it goes over a long distance. I'm not a machine specialist. My specialty is concrete, and that is one of the reasons. Koshnov is, as I mentioned, he started 15 years ago in the US with the gantry system, and he after a little while he couldn't progress further because a lot of people assume concrete is a very simple material. You go to Bunnings and buy and put some water there and that's concrete. As soon as you start working with it, you realize that this is a lot more than what you bargained for, because there's a lot of hidden problems. Even who's the guy who invented the light globe? Thomas Edison. Do you know that he spent majority of his life trying to build concrete house? He called it one pour concrete house. So you pour the whole thing, and there's one house, he actually built it in Washington, still around. But he had so many problems with concrete, cracking, plastic shrinkage, and he tried to fix it. Because the concrete is deceptively simple, but once you get there, so Koshnov said the same thing. He said it's a very, very complex material. So in terms of machinery, the machine side is relatively sorted out, because mechatronics engineers, robotics engineers, they can do significantly more advanced things than just 3D printer. So that side of things are relatively easy. The hardest part is the construction and the concrete, and so we are working on the right side now.
Well, can I ask maybe a slightly difficult question then? John, you mentioned before that Indigenous housing is a potential really fantastic application for this technology. How do we deal with the transport issue?
That's good, and Swinburne are also working in that area with transporting the prefab side. As far as that's the other thing that's got to be looked heavily into, and I think this comes down to where Jay's working, is in the materials side. To me, the object would be, if you're in an Indigenous community, that you actually got the materials already on site. It's there. You're just bringing the additives in and the equipment in to actually build them. That's still in its infancy. It's still being developed. At the moment, they're working mainly on the, like Jay said, geopolymers. They're working on hempcrete. They're working on so many different variations.
And maybe a huge opportunity for pozzolan clays as well, given that our soils are reasonably
rich. Yeah, definitely.
Mm.
I work with ASTM, ISO and Standards Australia, and Jay's sitting on the committees as well. So working around having a standard around 3D printing of concrete buildings, because that's one thing we don't have at this point. So early adopters who are coming in at this stage have got the hard tasks ahead of them of working with engineers, but in the same token, working with research areas in the way of testing and getting the test results done, and that so that they can get a certificate of occupancies. I mean, Contour 3Ds, it's not a certificate of occupancy they've got. One is it doesn't have a bedroom, so no one's actually living in it. So that's one of going to be the big hurdles moving forward, and that's something that the first often working together. I mean, Contour 3D Luton will come in the same thing. Cobod, who are here now, they'll come up with the same thing. Contour 3D are going to sign an agreement with Simmons Homes, so is a multinational and a high volume builder. So that will be interesting. Cobot are doing the same with a builder here. Luton, they'll be working. Whoever is going to be working has got to be working together with the builder.
Yes.
I mean, they've got to have building license.
Yeah.
You know, not just Tom around the corner grabs his printer, goes out and prints someone a house. You know, it just doesn't happen. But yes, it's definitely. I mean, to me, it's the way of the future. It is going to change, and we talk about it. And I think we talk amongst ourselves, a lot of the people, and we're all saying, geez, it's the perfect storm. So
the time is now.
The time is now. But again, I would suggest any companies that are really seriously or considering looking into it, get together with one of the research institutes and work together. That will move you a lot quicker than you trying to do it on your own.
Yeah, and who better than Swinburne with all of this incredible infrastructure?
Yeah.
And so, Jay, your team are looking at whether or not we can source local materials for the concrete mix. Have you got any insights there around, how we might be able to overcome that transport issue by potentially sourcing, local clays?
Yeah. So one of the advantages of concrete is 90%, 80% of the materials can be locally sourced. It's like aggregates and sand, and we need to bring the cement, which is only about 10 to 15% of the concrete. So if we can develop machineries that can go to remote areas where you need to build and source the local material and mix the concrete and supply and print it, that would be a real winner.
And what an incredible selling point as well, that you're living in a house which is built from local materials.
Local materials.
Absolutely incredible.
And there have also been some work using clay printing, and that has similar technology to concrete, or cement mixed with clay to stabilize and so on. So people are working with different type of materials similar to concrete. Yeah.
We're going to have some time for questions at the end. So given that this is a Zoom webinar, you've got two options in terms of asking questions. You can either pop it into the Q&A, and we have Hugh behind the scenes who is moderating our Q&A, or you can pop it in the chat function, which will be visible to everyone. So please feel free to ask any of the questions that you have. But before we jump into our Q&A session, I'd like to ask one more question of you both. I want to know if you could paint me a picture of the future. Where are we going? What does 10 years, 20 years, or date of your choice, what does it look like for 3D printing?
I'll let you go first on this one.
The one that we are imagining at the moment is that we call someone to say, okay, we got the slab done on the ground. Now we need to do the 3D printing part. Call the company, the concrete trucks arrives, the 3D printer arrives, they print the walls and roofs or whatever, and then they go away, and then the electricians and the plumbers come and finish it off.
So you have
That's
a
not
house
far
within a
away.
couple of days.
Not a couple of days.
No. We'd
within
like
a
to
few
think
weeks.
that.
Within a few weeks.
Yeah,
and
within
it's
a few
and
weeks.
And it's a lot more affordable, and you give the design in a CAD drawing that goes straight into the machine and is printed. So there's no someone looking at the drawing and measuring it and doing things. Everything is done smoothly from computer directly to the 3D printer and printed. So there's no manual thing involved.
I think so. I mean, Jay's exactly right. I mean, if you think back to the early 90s when printing first started happening here in Australia, I still remember doing a lot of talks around 3D printing. Listen, people thought it was fantastic, absolutely brilliant. But a lot of the industry said, John, it's a bit of a black art, it's great, but mate, the cost is just prohibitive. And quite a few said, listen, within 12 months it'll probably be gone. Well, yeah, you look at it now, it's a multi-billion-dollar industry. And they're estimating 38 billion by 2025. So yes, it is a big industry, and that takes in all additive, not just construction. It takes in everything, aerospace, all industries. So construction, as Jay said, is sort of coming in late into the printing side of it. But I believe, listen, within, what do you reckon, 10 years, I think it'll be definitely a norm.
And Australia is one of the best places to do this automation because the labor is so expensive, and we have people who are more educated, who are more interested in doing soft computer work. So it's basically this translate hard manual labor to more computer-oriented programming, but doing the same thing.
Requires skill sets.
Higher. So it's transferring from low-skilled labor to high-skilled work. And one of the contractors, the Spanish contractors, they're building something in Melbourne. He said he was trying to do automation in Spain and a few other countries. Very difficult to justify. Here, it's very simple because the labor cost is so high compared to the machine cost, and also the people here are more willing to learn and adapt. And he said this is the best place to introduce automation.
Yeah, definitely. I mean, the thing I've heard over quite a few years now is manufacturing's not sexy. You haven't got a lot of young people getting involved and growing through the ranks because it's not sexy enough. Well, let me tell you, additive is sexy, very sexy. And if you look at the construction side now, it's going to get sexier. So you'll see things change. I mean, the architects, they're never going to buy equipment and start printing things, but they're the ones that are going to be at the forefront with design around it, because once they get their head around, God, what can we do with this? It's absolutely amazing.
It's also a fascinating point that you touch on there, and sorry, I see there are questions, and I have more of my own. So, but we mentioned really quickly earlier about labour and the fact that was one of the ways that we reduce cost in this structure. But actually, the other side of that is it's also the jobs that are involved in this industry are skilled jobs.
Correct.
They're the machinists, they're the designers, they're the technologists, the concrete scientists. So it's a different type of labour that we're talking about here.
Totally.
Yeah.
So it's not a loss of job. It's creation of transforming from one skill set to the other.
Yeah. Yeah. Fascinating. Well, we have a question on the question line. Okay, so someone who is anonymous has a two-part question. Who should this person contact to get more details about geopolymer concrete that stays in the pipeline for days? We've got research happening here at Swinburne, so that's a great one. We can talk to that in a moment. And how did you get the rheology right? I believe a short duration mixing at the nozzle will make the concrete too liquidy. Well, we just saw a demonstration of this morning, and I can tell you that concrete after the additive was mixed in was not liquidy. But Jay, I feel like both of those questions are for you.
Yeah, so see, the geopolymer, until you mix the activator, it doesn't go hard. So that means if you take the activator and the binder, you separate it, then they're not going to go hard. And the other question is how did the rheology right? So that's we have published this work, so you can look at it, but we spent, our PhD student Shravan spent last 2 years trying to get the rheology right. We got a rheometer, so we do a trial and error with various mixes and adding lime and other material to get the rheology right. So you can look at our papers how we achieve that rheology. It's and also how to get the when we started, so it looks like this person already tried. It becomes too liquidy, but you have to get the mixes in the right proportion to split it, so it doesn't. It's not too liquidy. Yeah.
I think there is so many areas of research happening at the moment on variations on mixes and that, mainly because people are looking at green and sustainability. So this will change as time moves forward. And like Jay said, I mean, they're working in certain areas with various mixes, and of course there's people I've worked with over a few years, and one of them sitting out in the audience, and he's been very involved in the mix side of it. So I see a few things that will happen. I think he's working with Jay here at Swinburne and be putting up a bit of a small
little house.
A small little house, so that will be interesting.
Hi, Ali. So, question, is there any possibility to print metals and concrete at the same time? Which actually is a phenomenal question, because I wanted to point us over here and just have a look at this fabulous column, which is sitting behind Jay, and ask something quite similar, which was about the reinforcement and how reinforcement operates with this. But if I point you back just quickly, what are the options here? Can we print metal and concrete at the same time?
Victor Mescherin, as I mentioned, he has published some work in that area. He was actually doing reinforcements and welding and printing at the same time. But metal 3D print, I haven't tried it, and I think that's very complex, but the work that I've seen Victor has done, it looks really complex. So I think it's going to be difficult.
The only one, or the only couple I've seen is using metal fibre in the mix.
Oh, that's common.
Which is common. Yeah. And the other one, which is laying wire as the printer's moving forward. I mean, I know CNC Design have got that system which they've utilised, and they've utilised that in Thailand. Yeah. CNC Design and SCG in Thailand started back in 2017, and they printed up an absolutely magnificent building. They call it the Pavilion, but it's got a textured finish, and there again, that's what you can do with the 3D printing. So this building looks absolutely fantastic. Took 2 days to print. So they did that in situ on site, but you should have seen the size of the poly tent that was hung over the top of it, because in Thailand the weather is a bit of an issue, but they had the poly tent and they printed this up and did it. That has moved forward. They've got 3 printers now over there, and One of the things they're doing is, as we know, in South or in Asia, every company has a guardhouse. So what they've done now is they're producing many small slabs. They come in and they print the guardhouse, and it goes back through the assembly line, windows, roof, services, and everything all go in on the back of a truck, out, drop it on site, connect the services, and off they go. So they've been doing that, and they can do different sort of architectural finishes on each of these guardhouses. So they're not all the same, but they're doing that, and they've done well over 100 of these now. So that's phenomenal. There's another one sitting in HDB in Singapore, which is the Housing Development Board, where they're looking at printing up modules of apartments and actually taking them out the site and putting the modules in. NTU now in Singapore, they have ordered their printer. We'll head over next year. So that'll go, it's supposed to be installed in March next year.
Fantastic. So this really is booming as a concept.
It is booming as a concept, and like Jay said, we're starting to see it really start to take shape here.
So can I ask then, again, just pointing to this beautiful column just here, what would the process be in the actual construction to reinforce that, if this was going to be a part of the home?
Okay, so if you want to build a column like that, then this is the external shell, and then we can put the reinforcement cage inside and fill it with concrete. So in terms of design certification, it's very simple. It's just a column with the permanent formwork outside.
Yes.
So as opposed to a timber formwork which you take out and throw away, this becomes part of the final formwork. Similar concepts being used now with steel. So they use a steel pipe and fill it with concrete and just leave the steel as part of the structure. So it's called the permanent formwork. Bond-deck system, for example, is similar. So we can use 3D printing to print the external part, mold, formwork, and that can become the permanent.
And demonstrates that incredible flexibility of design and
correct.
Yeah, just those incredible forms that you're able to create, because I can't imagine you could create a mold for concrete that would look that special.
I mean, there's no surprise Cobalt is partnered, or the Cobalt is being partly bought by what's the company,
Black Buffalo. No, Black Buffalo is in
no, Cobalt partner with I'm very bad with names.
Yeah, you and me both.
But as a formwork
so
company,
they are a big formwork
they're partnering with a 3D printing entity now.
Because it's the formwork is what we're trying to print.
Yeah. Just phenomenal things happening in this space. We have another question on the line from Fahim. So lovely to see you online. I would like to know the application of the advanced numerical methods in developing large and full-scale 3D printing for future projects. I imagine that's a huge component here, really thinking through the structural and engineering elements. How do we start to equate some of the performance of 3D concrete?
In terms of structural analysis, we have published already how the material performs, and we can use the existing numerical methods. In terms of design, almost everyone's using Rhino and Grasshopper softwares for slicing and printing and so on. So the software tools are existing, but obviously you need the programming capability to adapt to the 3D printing.
So is that something that you would see is evolving at the same time as the 3D printing itself?
Yeah. So in terms of difficulties, it's not it is not the hardest part, but it requires the programming skill, coding skill, and the ability to create those things. So
Yeah. We had a little update to the question. So your question was relevant to advanced discrete element E methods and finite element methods.
So the discrete element models, so we have published using discrete element models. It's a PhD student, Roshan Jayathilakas. He did discrete element models to simulate the pumping of the concrete through the nozzle, the extruder, so we don't have to trial so many different materials to get it right. So by modeling, we can decide how many number of flights the screw should have, what's the diameter, what's the extruder should be, to an extent, and then we can start making the nozzle. So discrete element models being used, and we have published that work already.
Fantastic.
Yeah.
Which again, I think, points back to the earlier question we had around, where do we find more information out about what's happening? So you and your team are really fabulously published in this area. So where can they find more of your work?
Well, if you go to Google and Google Scholar and
Google Jay.
and we have published something like I think nearly 70 journal papers in this area, and most of our work is already there in Google Scholar or Scopus or somewhere, and you can find our papers. Yeah.
Fantastic. So Dr. Jay Sanjayan, absolutely recommend you have a look for him on Google Scholar and read some of those great articles. And John, you are really at the cutting edge here in Australia in terms of what industry is doing, and with your own consulting firm, John Croft Consulting. How do we keep up to date with what you're doing?
Well, as I've just finished with CNC, you'll start to see me start to post a lot more of what's actually happening. I'm talking to a few companies at the moment, which will start to see things happening. I mean, coming from running the additive manufacturing hub, I'd like to see something similar start around construction on additive, and I think that would be more than beneficial to industry to be able to actually see things being done, and that's even being talked about, teaming up with Jay. I also am now chair for Prefab Oz for additive manufacturing in construction. We will have our first get together on the 29th, I think, of November. Watch that space, have a look at my LinkedIn, it'll go up. Where we're going to start the focus group on additive manufacturing. So that could go on for a year or two. Jay, of course, is definitely one that's going to be involved in that as well. We'll have about two, because there's end results that we want to get to of why the focus group is being put together, and start to publish things that are coming out of that.
Fantastic. So watch your LinkedIn. That's John Croft. So I think we have time for one more question, and I think this is a really beautiful question because it's going to leave us on a sustainability note, which is something we are passionate about here at SmartCrete. Shravan, thank you for your question. If we want to use the low CO2 cement Swinburne developed, how much would the licensing cost, and does Swinburne hold a patent for it?
No, we couldn't get the patent because Shravan was too quick to publish it. So
one of the dangers of research.
I wasn't very pleased with that, because he put in a few sentences in one of the papers, and that stopped us from getting the patent. Yes.
What a shame. But now that knowledge is freely available to the world. So fabulous. And Swinburne really is doing incredible work in this space. So highly recommend that you jump onto the Swinburne website, jump onto Google Scholar, have a look at some of that great work. I want to thank you both so much for a really fascinating conversation. It could not have happened in a more incredible space, surrounded by these beautifully 3D printed products. And thank you all so much for joining us. We will have this video available within about a week and a half online, so that we can share it, and you can share it with anyone else in your network that might be interested in this space. So we look forward to seeing you at the next Clinker Chat. Thanks for joining us.
Ciao.